All right, today we're going to go over some practice problems using our titration equation. I've got this worksheet off my website, hopefully. First problem reads, how many milliliters of a 1.5 molar nitric acid solution are needed to just neutralize 50 milliliters of a 0.75 molar lithium hydroxide solution? All right, so we want to remember our equation. The molarity of our acid times the volume of our acid equals the molarity of the base times the volume of our base. We want to go ahead and identify all of the variables. I like to write these off on the side. And then through the word problem, we can identify what's what. So 1.5 molar nitric acid, it tells us right there, that's our acid. The capital M is the units for our molarity. So I'm going to write that down on my margin. How many milliliters of that acid? That's our unknown. What's the volume? All right, the rest of it is our base, the lithium hydroxide. This OH here, that is the clue that this is our base. So it's 50 milliliters. That's the volume of the base. And the 0.75 molar is the molarity of the base. All right, now we've got a little bit of algebra to do, and that's it. This is the science part done already. We want to find the volume of our acid. We need to isolate this variable, so we want to remove the molarity of the acid. Because things are multiplied, I am going to move it by dividing both sides by the molarity of the acid. These cancel out on the left, which leaves us with the volume of the acid is equal to molarity of the base times the volume of the base divided by the molarity of the acid. Now I can plug things in. The molarity of the base is 0.75. Volume is 50 milliliters. All of this over 1.5 molar. The units of molarity will cancel out, and that leaves us with an answer of 25 milliliters of our acid. All right, we want to check that that answer makes sense now, right? That's the last step in a science problem, is checking, does it make sense? The acid was twice the molarity, right? 1.5 compared to 0.75, it was twice as concentrated. And so the volume needed was half as much. And that works out with everything we'd be expecting here. All right, the second problem is very similar, just uses the acetic acid and vinegar, which the trick here is knowing how many hydrogens come off of this particular acid. Acetic acid does have 4 hydrogens, but we only are going to ionize one of them. The rest of this is the acetate ion, which doesn't move. All right, so what's the concentration of vinegar? If 10 milliliters will just neutralize 18.2 mils of a 0.5 molar solution. So again, I'm going to list all of my knowns and unknowns as a good starting strategy. All right, so 10 milliliters of the vinegar. The vinegar is the acid. It's 18.2 milliliters of the 0.5 molar NaOH. All right, this is the base. All right, the base has hydroxides. Vinegar is an acid. What is the concentration of the acid? Now we just use the same equation. It's good habit to write down the equation each time we're doing a problem. And again, the farther you get along in science, the more often you're going to isolate the variable first. All right, we're dividing both sides by VA because this is molarity times volume. We're going to divide the item that we want to move. All right, this way it just helps us keep it neater and cleaner work as we're moving the symbol instead of a number with units. All right, now I just plug things in, and I can go ahead and calculate the answer after that. So now I just go back to what I wrote down a moment ago. All right, this is the molarity and the volume of the base, and then I'm dividing by the volume of the acid. What's nice about listing these out beforehand is I don't have to think about that chemistry part when I'm doing the algebra portion here. Unit-wise, my milliliters cancel out, and that's going to leave me with an answer of 0.991 molar vinegar. And this is two examples then of how to do the titration equation, how it applies to us in a first-year chemistry class. I want to take this next level. We've got to look at acids and bases that have more than one hydrogen ion or more than one hydroxide ion. So in this example, we've got KOH and H2SO4. We still have the same equation, MAVA equals MBVB. If we're being specific, though, on our reference table, the MA represents hydrogen ions, not really the acid. In a first-year chemistry class, a lot of our acids and bases have only one hydrogen or one hydroxide. But the KOH here does have 1 mole of hydroxide. The acid has 2 moles of hydrogens, though. So we've got to take that into account here. What we can do is, because the left side of this equation is counting or calculating the moles of hydrogen, if every mole of acid has 2 moles of hydrogens, I just need to double this side. Because the side of the base only has 1 mole of hydroxides, I don't need to multiply that by anything, or I could just do times 1 if I really wanted to. All right, so now I can plug things in again. This is our base we recognize by the hydroxide. It's 1.20 liters, 0.26 molar. And the acid is 0.78 liters, and we aren't sure what the concentration would be. So how do I find MA then? I'm going to divide by 2 times VA. Those will cancel, which leaves us with the molarity of the acid. All right. What this tells us really is that the molarity of the acid will only need to be half as strong because there's twice as many hydrogens. And now I just plug numbers in and do the math in my calculator. My liters will cancel, and I should get an answer of 0.20 molar. See if that makes sense. Again, that's about the same concentration as the base, but we used more of the base, but the acid had double the number of hydrogens, so I think I'm going to accept that answer looks pretty good. All right, my last question for you this time around. We've got now an acid, phosphoric acid, has 3 hydrogens, and that hydroxide has 2 OHs. And so what we're going to do here is we've got to manipulate both sides of this equation. I'm going to write the equation out here. And now we'll go ahead and list our knowns and our unknowns down the side one more time. The phosphoric acid is the half molar. We don't know the volume. The base is 0.30 molar and 20 milliliters. But now what do I want to do to alter these equations? Don't overthink it. Look at the acid and see how many hydrogens there are. Because it's H3, we need to triple the acid side. Remember, we're counting moles. The base side has 2 hydroxides, so we double the base side. All right, really we're doubling the molarity portion, but we're really, in the end, doubling the moles. All right, so now I'm trying to find VA. I will divide by 3 times MA. That leaves us with the volume of the acid is equal to MB times VB over MA times 2 over 3. Plug in our numbers from the side, not forgetting our factor for the different acid and base we've used, and that should give us an answer of 8.0 milliliters. Again, similar to the 20 milliliters we had of the base, but the acid was more concentrated and had a higher number or ratio of ions, so we needed a lower volume to neutralize it. And there you have it. Titration problems worked out. Good luck, and hope that helps.